In October 2017, something extraordinary happened. Unlike anything we'd ever seen, an object came from deep interstellar space and flew right past us. We call it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. And that's exactly what it was, the first known interstellar object to enter our solar system. But here's the strange part. We didn't even know it was coming. When telescopes spotted it, it was already on its way out. No warning, no time to redirect a spacecraft. Just a blur across the sky, here and gone. This is the story of the object we nearly missed, how it challenged everything we thought we knew, and why some still wonder if it was just a rock or something far more mysterious. On October 19, 2017, something unexpected appeared in the sky. The Pan-STARRS 1 telescope in Hawaii, designed to scan the heavens for near-Earth objects, picked up a faint, fast-moving point of light. At first, it looked like just another asteroid, one of many we've cataloged in our cosmic neighborhood. But as astronomers tracked its path, something didn't add up. This object wasn't orbiting the sun like our planets or asteroids do. It was on a hyperbolic trajectory, a one-way ticket into and out of our solar system. That told scientists it came from outside. It was the first confirmed visitor from another star system. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first, fitting for something that had never been seen before. But here's the strange part. By the time we spotted Oumuamua, it had already passed its closest point to the sun, looped around, and was speeding away. It was already on its way out of the solar system. We missed its arrival. Came and went, and we only caught a glimpse during its escape. Because of that, we had only a few short weeks to study it. No time to send a probe. No time to get a better look. Just enough time for it to raise questions we still haven't answered. This wasn't just a discovery, it was a wake-up call. We had seen our first interstellar object, and it had nearly slipped past unnoticed. When Oumuamua was finally spotted in October 2017, it had already passed the sun and was racing away from Earth. So, how did we miss it? First, let's talk about speed. Oumuamua was moving at a staggering 87.3 kilometers per second, far faster than anything we've launched from Earth. It wasn't orbiting the sun like most objects in our solar system. It was just passing through. That high velocity gave us only a tiny window to catch it before it vanished into the void. Next, size. Despite the attention it got, Oumuamua wasn't a massive object. It was only about 100 meters long, roughly the length of a football field. In space terms, that's incredibly small, especially compared to the vastness of the sky. Then there's reflectivity. Unlike comets that light up with glowing tails, Oumuamua didn't reflect much sunlight. Its surface was unusually dark and non-reflective, meaning it didn't shine brightly like most objects we spot with telescopes. And finally, our observation limitations. Most telescopes don't scan the entire sky all the time. They focus on narrow regions, looking for changes. Oumuamua came from above the plane of the solar system, a direction we rarely monitor. By the time it crossed into our view, it was already leaving. In short, it was fast, it was small, it was dark, and it came from a place we weren't looking. It slipped past all our usual filters. The truth is, this interstellar visitor had already come and gone before we even knew it was here. When astronomers first analyzed Oumuamua's movement, they expected something familiar, like a comet or asteroid. But what they found defied expectations. First, the shape. Unlike the round or potato-like forms of most space rocks, Oumuamua appeared elongated. Estimates suggest its length-to-width ratio was at least 5:1, possibly as much as 10:1. Picture something the size and shape of a long, dark cigar tumbling through the cosmos. No known natural object in our solar system has proportions quite like this. It raised eyebrows. Was this just a fragment from another system or something more engineered? Then came the acceleration mystery. As it flew away from the sun, Oumuamua began to speed up, but not in a way we could easily explain. Normally, a comet would accelerate as ice sublimates off its surface, releasing gas like a tiny rocket engine. But in this case, there was no visible cometary tail, no gas cloud, no outgassing signature. It was silent, dark, and still it accelerated. Some proposed that Oumuamua might be shedding hydrogen, too light to detect. Others speculated it could be a light sail catching solar radiation, something artificial. And then there was its rotation. Instead of spinning on a stable axis like a top, Oumuamua was tumbling, its spin changing erratically. This suggested that the object was not only oddly shaped, but also likely had a non-uniform interior, possibly hollow or broken into different densities. Put together, these strange behaviors made one thing clear. Oumuamua didn't fit neatly into any known category. It wasn't just another space rock. It was a puzzle, an interstellar enigma flying through our backyard. And just as quickly as it arrived, it disappeared into the depths of space. One proposition suggests that Oumuamua is composed of solid hydrogen ice. As it approached the Sun, sublimation of hydrogen could have produced the observed acceleration without detectable gas emissions. However, subsequent analyses indicate that such hydrogen icebergs would likely dissipate during interstellar travel, casting doubt on this theory. Another theory posits that Oumuamua is a fragment of nitrogen ice, possibly ejected from the surface of a Pluto-like exoplanet. This composition could account for its high reflectivity and non-gravitational acceleration due to nitrogen sublimation. The absence of typical cometary activity supports this hypothesis. This scenario suggests that Oumuamua originated from a larger body torn apart by tidal forces during a close encounter with its parent star. The resulting fragments could be ejected into interstellar space, explaining Oumuamua's elongated shape and trajectory. A more speculative idea comes from Harvard astronomer Avi Loeb, who proposed that Oumuamua might be an artificial light sail sent by an extraterrestrial civilization. This theory arises from its unusual acceleration and lack of a visible tail. However, no direct evidence supports this claim, and the scientific community remains skeptical, favoring natural explanations. While each hypothesis offers intriguing insights, none conclusively explains all of Oumuamua's anomalies. Its brief visit left us with more questions than answers, highlighting the need for improved detection and observation of future interstellar objects. When Oumuamua appeared, it was already leaving. We had no chance to turn telescopes toward it in time, no way to study it up close. But next time could be different. Enter the Vera C. Rubin Observatory, set to begin operations soon. Located in Chile, this observatory is unlike any we've had before. With its massive 8.4-meter mirror and the Legacy Survey of Space and Time, LSST, it will scan the entire night sky every few days. That means it won't just see what's out there. It'll track what's changing, what's moving, what's arriving. This level of detail and repetition will make it far more likely to catch fast-moving interstellar objects, like Oumuamua, before they've already passed us. Why does this matter? Because early detection means more time to prepare. If we spot something coming into the solar system soon enough, we could mobilize telescopes, plan close observations, maybe even launch missions to intercept. A few extra weeks, or even days, can be the difference between missing a visitor entirely and learning everything about it. Oumuamua was a wake-up call. Now, we're building the tools to make sure we're ready for the next one. Because the truth is, interstellar objects are out there. And they're coming. The only question is, will we be ready next time? Oumuamua came and went in the blink of a cosmic eye. It slipped past our planet before we even knew it was there. Proof of how much we still miss in the darkness between the stars. Despite our powerful telescopes and decades of space exploration, this interstellar visitor caught us off guard. Why? Because our view of the cosmos is still narrow. We're watching a vast sky with limited eyes. But its passing left more than questions, it sparked a new urgency. What else could be out there? How many cosmic travelers have we overlooked simply because we weren't looking in the right place at the right time? Fortunately, change is coming. New observatories like the Vera C. Rubin telescope will scan the skies constantly, catching fast-moving objects long before they're gone. Missions dedicated to interstellar science are already in planning. The next time something visits us from beyond the stars, we may not just see it, we may even reach it. Oumuamua was a mystery, yes, but it was also a mirror. It showed us our limits, but it also pointed the way forward. Every missed opportunity is a lesson. Every strange visitor is a challenge. And every discovery begins with curiosity. Because the universe is full of wonders. Let's make sure we don't miss the next one.